Second part of the video that we'll do from absolute value functions on. So we just did the identity function last, and now we're going to work with the absolute value of x. So what we want to do is start by making a table, right, of the parent function, which is the absolute value of x. So what I'm going to do here is just make these over here off to the left and a little bit down, right? So I have x and y. Right, some points that we definitely want to use here are -2, and the absolute value of -2 is 2, -1, absolute value of that is 1, 0, 0, and 1, 1, and 2, 2. Oh, 1. There we go. Right, so these are just 5 points on the parent function, which is the absolute value of x. Right, we kind of know what it looks like, something like that. Right. So this first one, we have the absolute value of -3x. So since the negative is on the inside, what's going to happen is that's actually a reflection over the y-axis, so that all of the x coordinates are going to change, right? So if you had, like a point over here, and you reflected it over the y-axis, it'd be over here now. And that basically, the y value stays exactly the same. It's the x value that changes. So we want to make all of these x values the opposite. So instead of -2, we're going to have +2, +1, 0 is still 0, but 1 becomes -1, and 2 becomes -2. Now, does it really do anything? No, because if you look at the coordinates, they're the exact same thing. Just now you have, them in a different order, but same thing. But then what's next is, since the 3 is on the inside of the bars, that's, from your video, that's going to be a horizontal compression because it's bigger than 1. So that means instead of multiplying all the x coordinates by 3, you're going to divide them all by 3. So we're going to make the second little bar over here. I'll just kind of keep going to the left. Right, so instead of -2, you're going to have negative, if I can get it, 2/3. Instead of -1, you're going to have -1/3. Instead of 0, well, you still have 0, because 0 times anything is 0. Instead of, oh, actually, those first two are positive. I forgot we did the reflection first. Normally, we can do stretch and strings first. It really won't make any difference, though. I know I put them in that order, but you can do them in either order. -1 is -1/3. And the last one is -2, so you get -2/3. Right, so that takes care of both the negative and the 3. So literally, your new x coordinates are right over there in the purple. The y coordinates, we didn't change, right? It was all horizontal changes going on, reflection and a stretch, or actually a shrink, I'm sorry. So those are the new coordinates we can graph, and on our table, right, we have them. So we have 2/3, 2. So if I go over to 2/3, 2, I'm right there, right? And then I have 1/3, 1, 0, 0, -1/3, 1, and -2/3, 2. Right, so like right there. And you get the same, it's still a V shape, but you can see it's horizontally compressed or shrunk, right? I think the video said compressed. I use shrink a lot. It's the same thing, right? It's certainly a lot, less horizontal than it used to be. So that's kind of that one. If we did the second one, a little bit more involved. Let me erase the rest of this, right? But it would pretty much be the same thing. So we have 0.5. Well, actually, we'll just talk about it. We don't have to do the whole chart, but you'd start with the same 5 points, -2, -1, 0, 1, and 2. And then what you would do first is you would do this horizontal. This one actually be a stretch, right? It's between 0 and 1, so you're actually stretching it. So it's a horizontal stretch by a factor of 2, because it's always 1 divided by, in this case, 1/2, which would be the same thing as 2. And then from there, you would go -3. So you would move all of the x coordinates to the right 3, and then you would do your up 2. I'll do this next one, which is kind of similar. It has similar things going on, so we'll take a look at this one. And that one is with the square root. So we'll do this one after we do the parent. So a good habit always to do is to graph the parent first, and then figure out what the changes are in your table. So this first one, the parent function, I'll do it in red. All right, so this is the parent right here. We have the absolute or square root of x. So make a little table. Right? So I have, let's see, if I plug in 0, I get the square root of 0, which is 0. If I plug in 1, I get the square root of 1, which is 1. I'm going to plug in 4, right, because the square root of 4 is 2. And the last one I'll do is 9. The square root of 9 is 3. Right, so those are the 4 points you really need for every square root function. The absolute value, you could do -2 to 2. Here we're going to go 0, 1, 4, and 9. And we can put those on the graph. So we got 0, 0, 1, 1, 4, 2, and 9, 3. And we get a graph that looks like that, right? So from here, right, now we're going to worry about these changes. So I'm going to skip this second one. If you want to do it on your own and pause the video and join me when I start the second one, you can. Otherwise, we can just go ahead with this one. So now I have 4, and then square root of x plus 4, and then plus 4 on the end. So I'm going to do the vertical stretch first. So I'm going to multiply all of these y coordinates, because it's a vertical stretch, right? Vertical is up and down. Y coordinates are up and down. That one kind of makes sense. So we're going to multiply all the y coordinates by 4. Right? So 0 times 4 is still 0. 1 times 4 is now going to become 4. 2 times 4 is now 8. 3 times 4 is 12. So that took care of this 4 on the outside. Right? I just did it right in the chart. Now, if you want to graph this one and use like a different colored pencil, you can, right? And you're just going to graph each one separately. But you can just keep it in the chart here and just kind of keep in mind where you are. So that takes care of that. Now I'm going to do the plus 4 on the inside. So I'll do that one right here on the inside. So what I'm going to do is, you got to think, plus 4 is the one that goes against your common sense. That actually means left 4 from last class. So now all of the x's, since you're going left and right, are going to go to the left 4. So again, you could just graph it and then move your graph left 4, or you could just work in your table. I'm just going to work in the table. But, so if I have 0 and I move it to the left 4, I'm going to have -4. If I have 1 and I move it to the left 4, I have -3. If I have 4 and I move it to the left 4, I have 0. And if I have 9, I move it to the left 4, I have 5. Right, so that basically right there takes care of this plus 4. Again, if you want to use a different colored pencil and just graph these ones now, so those x coordinates with the green y coordinates, you can do that and then just pick your graph up 4. What I'm just going to do though is this last table, I'm going to take care of the last transformation, which is this one right here, this plus 4. So since this one's on the outside, we're going up and down. So that's going to affect the y coordinates, not the x coordinates, right? Up and down, the y's are being affected. So instead of 0, if I have to add 4, I get 4. If I had 4 and I add 4, I get 8. If I had 8 and I add 4, I get 12. And if I had 12 and I add 4, I get 16. So that one might be off the graph a little bit. But now that we've taken care of all the translations, these are my coordinates that are left, right? So these are my x's and these are my y's. So I have -4, comma, 4, and I'll do the final graph in black. So I got -4, comma, 4, which is right there. And if I look here, I got -3, comma, 8. So -3, 8. And the next one I have 0, comma, 12, which fits on mine. That last one, what was that, 5, comma, 16. I'll just throw it somewhere around there, but it's going to be off a little bit. It'll be like way up here or something. Right, so that's kind of the graph that we get. And that's the final graph, right? So you can look at it and say, yeah, it's definitely moved left 4, which is good. It's definitely moved up 4, which is good. And it's definitely vertical 4 times more vertical actually, which is good, right? All comparing it to the parent. Now, how do you make sure you have the right points? Go ahead and plug in one of the points, right? So if we wanted to plug in 5, just to check, when we plug it into the equation, it should give us 16. So just to double check, if we plugged in 5 for x, we would have 4 times 5 plus 4, which is 9. And then the square root of 9 is 3. So 4 times 3 would be 12. 12 plus 4 is 16. Perfect, right? All of your points you can double check by plugging them into the equation. Plug the x's into the equation, make sure they spit out the y's, and you'll make sure that you have the right graph. Okay? Next is the quadratic. So the quadratic we've certainly done a lot of. It's the same thing as vertex form here, really. I mean, think about you're going left and up or right and up or something. So the parent function, we'll just graph it really quick. But your table, it's almost going to be like your absolute value table with the same x coordinates. You'd have -2, -1, 0, 1, and 2. And when you plug those in, right, -2 squared is 4, -1 squared is 1, 0, 1, and 4. Right, but we kind of probably knew that already. So your graph is going to look, just the parent function. Again, it's always a good idea to graph this one first. And from there, right, this first one would just be a vertical stretch by 3. So you would take all of these y coordinates and just multiply them all by 3, and then you'd be done. I'm going to take a look at this one. And I'm just going to move the 3 over here so that's in vertex form. So it's 2/3 x minus 6 squared and then plus 3 on the end. You can certainly do that. And don't get confused if you see it out in front. You can move it around. Right, but here you'd see that we're going to have to, first things first, we would have a vertical shrink by a factor of 2/3. So all of these y coordinates we'd want to multiply by 2/3 and do it over here. I'm just going to skip this one for time. -6, you would move to the right 6, so you'd want to add, +6 to all of those. And then +3, you would take whatever y's you had and add 3 to each one and then graph it. If you want to pause the video and do that, you can. You'd have a graph that probably looks something like that, general shape. But again, you could just do that in the chart and then graph the last one and check it by plugging in your x's and making sure that they have the right y's when you graph it. Okay, cubic function, which is over here. So we're going to start with the parent function again, which, I'll do that one over here in green. So we have x and y, right? So now with this function, we get the same 5x coordinates, -2, -1, 0, 1, and 2. And when I plug in -2, I get -8. Plug in -1, I get -1. 0 is still 0. 1 is 1. 2 is 8. So those are your main coordinates for the parent. So I got -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Oops. So just connecting the dots. All right, that's the parent function. I missed a little bit, but not a big deal. So if I looked at this one, I am going to first reflect it. And this is a reflection over the y-axis because it's on the outside. So if it's, reflection over the x-axis because it's on the outside. And when it reflects over the x-axis, like this point right here, reflected over the x-axis, the x value doesn't change. It's the y value that changes. So here, since it's on the outside, we're just going to make all of our y values the opposite. So I'm not going to make a separate chart here. I'm just going to make the -8, +8, +1, still 0, -1, and -8. Right? Easy. So that took care of the negative sign. The next thing I'll do is I'll use this +1, which just means left 1. So over here, I'm going to draw a separate chart. So if I have to go to left 1, -2 is going to become -3. -1 is now -2. 0 is now -1. 1 is now 0, and 2 is now 1, right? And that takes care of the +1, which is left 1. The +1/4, right? You can just add 1/4 to all of these. So now you got 8 and 1/4. If I can draw it, there we go. 1 and 1/4. I'm just adding 1/4 to all of these. Instead of 0, it's just 1/4. When you're dealing with negatives, it gets a little trickier. -1 plus 1/4 is actually -3/4. -3/4. And -8 would be -7 and 3/4. If you guys can even see that, it didn't come out that well. Right, but those are all your points. You just took care of the plus 1/4. We did them plus 1 before. So you can just graph them, and then you'd be done with that one. So -3. So these are the x's, and these are my new y's. So -3, 8 and 1/4, which is right there on the graph. -2, 1 and 1/4. -1, 1/4. 0, -3/4. And finally 1, -7 and 3/4. And that's what we got. Right, so we took care of all of those, and that would be the final graph. Again, how can you check it? Well, just take any point like 0, -3/4, plug it in, make sure it makes sense. Right, so 0 plus 1 is 1, 1 to the third is 1, so you get -1 plus 1/4. Yep, -3/4, perfect. The last one we do is the reciprocal function. So we're just going to look at this one. But don't get confused when you see the 5 on the top. You can pull it right out in front. So that instead of 5 over x, 3x plus 2, you can say 5 times 1 over 3x plus 2. And then plus 5. And that's the same thing. But at least this way you can see that it's definitely a vertical stretch by 5 if you pull it out in front. So it's 5 times that, right? So your 6 points for rational functions, there's 6 of them instead of 5 of them, or 4 of them. These are the ones you want to work with. So it's going to be -2, -1, -1/2, +1/2, and 1, and 2. Right? And when you plug all of these numbers into 1 over x, which is the parent function, you get -1/2, -1, -2, dividing by 1/2, same thing as multiplying by 2, 2, 1, oops, and 1/2. And so we can graph that. And that's this one. And here. And we get that. Right, that's the parent. So again, if we wanted to do 5, we can do the 5 first, this 5 right here. So all of the y coordinates are going to be multiplied by 5, right? And again, you would get something, multiply it by 5. Then we could do the vertical one where we divide all of the x coordinates by 3 because it's a horizontal shrink. So all of these x coordinates you divide by 3. Then you could subtract 2 from them and keep going. And then finally you could add 5 and your final columns would be this one and this one. I won't. You can certainly check your answer on your graphing calculator though and check it that way. But it's exact same steps as we've done before, and just to save time I won't. But you'll see a graph that's actually really well stretched out. It's actually hard to see after you graph it. You can check your graphing calculator and make sure. And that's it. So once you finish the video, hopefully you go back and you do all these other ones that were on there. You can start the homework, which is 19 to 49 odds, and then I think it's going to ask you to graph a lot. Just pick 5, but just try and pick 5 different ones, right? Don't do 5 absolute value functions. Do 1 absolute value, 1 square root, 1 rational, 1 quadratic, 1 cubic, and you should be good. Any questions, you can email me. This is definitely a harder concept, so please rewatch the video if something didn't make sense. You need to make sure you know how to do horizontal and vertical stretches and shrinks. because you're going to be assessed on them as if I was there, okay?